Most developers are likely already familiar with Visual Studio Code. Even those who are hearing about Visual Studio Code for the first time have probably heard of Visual Studio. Visual Studio Code is a different identity from Visual Studio, but these days, many developers are using Visual Studio Code. In my case, even if it's not specifically Arduino, I do development related to various languages like JavaScript or Python, and developing with Visual Studio Code is quite convenient. There are various methods to install or download Visual Studio Code, but you can simply visit the official website and install it according to your desired operating system. I won't go into detail about the installation this time. I'll just explain how to control Arduino within Visual Studio Code, assuming that you have already installed it. First, I will create a folder to start an Arduino project and prepare everything inside it. Then I will try writing Arduino code using Visual Studio Code. For now, I will. Let's create a folder called Arduino test. I created a folder called Arduino test, and if Visual Studio Code is installed along with something like the CLI, you can call Visual Studio Code directly like this. This is how it has been called now. In my case, I already have several extensions installed related to Visual Studio Code, and if you click here, you will find the extensions that can be used in Visual Studio Code. While Visual Studio Code may not have a wide range of features, with just the basics, you can access an incredibly vast array of functionalities through its extensions. By clicking here, you can easily and conveniently search for extensions, and if you search for Arduino, you will see the Arduino extension created by Microsoft. Please install this, and when you install it, it is based on the premise that Arduino is already installed on your PC or your Mac, so you can use this extension. In my case, I have already installed it. Next, I will create an Arduino code named Arduino test. It is Arduino test.ino, which is the same name as the folder. And in the case of Visual Studio Code, there is a palette menu that allows you to bring up this menu. Here, there is a command called initialize for Arduino. Once you call this, it will prompt you to select a board, and I will choose Arduino Uno. You can search for it, and when you do, Arduino will run. However, the files related to compilation and other Arduino-related components are not all built into the extensions. The actual compilation and core functionalities rely on the existing Arduino setup, so there is a back and forth process. When building or uploading, I often switch back and forth to Arduino, which is unavoidable. However, the reason I use Visual Studio Code is because of features like syntax checking and error checking. Additionally, I will mention later that there are snippets, which are essentially template codes that expand when I type just a few characters, significantly boosting my development productivity. That's why I use Visual Studio Code. So I have initialized the Arduino project for now. Here, I could enter a template, but I'll just do it as usual by writing void setup. I will now proceed to enter the void loop function, which is a crucial part of the program. Here, the serial is automatically selected like this, just like the serial begin. In this way, I will randomly write the code every 3 seconds. This means that every 3 seconds, a new piece of code will be written randomly. At this point, we will check in the Arduino IDE, which is the verify function. The Arduino IDE has a built-in verify function that allows us to check the code for any errors or issues. If you want, you can set up all these shortcuts in VS Code as you wish. Visual Studio Code, commonly known as VS Code, allows you to customize and set up various shortcuts according to your preferences. When you verify, you go over here and you can see that it has been verified. The verification process will show you whether the code has been successfully verified or if there are any errors. If I wrote the code incorrectly, then just like in the original Arduino, error messages will appear right here. For example, it will indicate that there should be a semicolon before line 1, like this. Error messages will help you identify the exact location and nature of the mistake, such as missing semicolons or incorrect syntax. Then, let's try uploading it. If I upload it now, an error will occur because you need to set it up first. This is because the port settings are not configured. Before uploading, it is crucial to ensure that all necessary settings, including port configurations, are correctly set up to avoid any errors. In the palette menu, if you select the Arduino port, a select serial port option will appear. Right now, I have connected the Arduino Uno to the port at the very bottom. If you click this, the current port will be selected, and in this state, if you proceed with the upload, it will similarly execute on the Arduino side while uploading. Sometimes, the Arduino screen may not appear, and the upload may fail. In such cases, just wait a moment until the uploading progress bar disappears, and then simply try again. You will see that the Arduino appears and it will indicate that the upload is complete. Now the upload is successfully complete, and you can also verify the serial monitor here. Before that, you need to configure the baud rate to 9600. Additionally, you will notice that a VS Code directory is automatically created in the project. In the Arduino JSON file, information about the port, board type, and sketch file is inputted. So, if you plan to store this to GitHub or similar platforms, make sure to incorporate all local information, including the VS Code directory, when you push to Git. If not, you can omit it from Git. Now that we have set the baud rate, let's open the serial monitor. When you open the serial monitor, it will appear directly in the terminal below. It's still not connecting well at all, so please close the Arduino and then open it again. And please try to reconnect it again. Serial The monitor is acting up, but if you open the serial monitor now, you can see it displaying hello first, and then world in that order. This is a simple demonstration of how serial communication works. For those who want to analyze serial communication in a more complex way, using CoolTerm, which I showed a few times during my lectures, is the best option. CoolTerm is a versatile and powerful tool that allows for detailed analysis and debugging of serial communication. Additionally, the Arduino IDE has a library manager and various related examples available. The library manager is a convenient feature that helps you find and install libraries easily. So, if you type Arduino, you can find examples like built-in examples or custom library examples, just like you would in the IDE. These examples are very helpful for learning and experimenting with different functionalities. You can also search for libraries in the library manager and add them in this way. This makes it easy to expand the capabilities of your projects. In this session, I explained how to use Arduino in VS Code. In the next session, I will cover one of the features of VS Code called snippets, where I can designate a few shortcuts so that when I input them, the template is automatically filled in. I will explain that in detail next time. So I will see you then.